Hello, we're in Algebra 2. This is Chapter 7, Section 4. This is page 3 of the notes. We have this example on finding inverse functions. They make it look like Part A is something to do, but if you read, they've just done it for you. You're supposed to find the inverse of y equals log base 3/2 of x. And all they did is they did that swap from the logarithmic form into the exponential form, and then you're done. It's a backwards version. To be honest, they shortcutted it. It's probably not worth too much of your time. Here, though, Part B, they did the thing where they are also scaring you with new notation at the same time. Here we go. It says y equals ln, and ln is log base e. Every time you see ln, which by the way stands for Logarithmus Naturalis, which is the Latin version of the words natural logarithm. Everything is backwards in Latin because it's like French. It's log base e because it's the natural logarithm. It's the logarithm base of the natural number, which is e, which is what we talked about in the last unit. Anyway, so y equals log base e of x minus 4. So down here, boom, Part B, we're meant to find the inverse. Well, got to start by pulling the old switcheroo, where you swap the x's and the y's. Any inverse problem is swapping x's and y's. We did that a couple chapters ago. Then you got to change it to exponential form. Now remember, I wrote ln, but in my mind I'm really thinking log base e. And that's important because when I switch it to exponential form, that means I'm going to say e to the x equals y minus 4. That's the exponential version of that logarithm equation. And then when you solve for y, you add 4 to both sides, so y equals e to the x plus 4. Boom. And then apparently you have to write it again. I don't know why they want you to write it twice. But hey, that's example 4. Pretty straightforward. A little strange where they just make this ln thing come out of nowhere. You have to think in your head log base e. I recommend you just cross it off on your paper every time you see it and you rewrite it log base e. Just don't mark up the textbooks, please. Alright, so look at the checkpoint. Give yourself a chance, please, and try numbers 5 and 6 on your own. These can be found after example 3, or actually in example 3, excuse me. So I'll pause for a few seconds so you can pause the video, try them, then start the video and see how you did. Okay, so the answer for the first one is 7x. First of all, the log thing is missing a base 10, so it should be log base 10 of 7x. It's actually correct to write it without the base, but like that ln thing with the e, if you see base 10, if you see no base at all, you should just go ahead and write in the 10, except not in your textbooks. For number 6, it's a little harder. You've got to change that 27 into a power of 3. And 27 is 3 to the third power. And so you can go ahead and change that into 3 to the third to the x. Use the power property. That's 3 to the 3x. Boom, your answer is 3x. Now, give yourself a chance to learn again. I'm going to wait a few seconds so you can pause this. Go back, look at example 4. Give your best shot, please, on numbers 7 and 8. And then I'll come back and show you. Okay, so number 7, it's like part A on example 4, but I didn't think they did a very nice job of showing how that worked. So here's what I did. We start with the switcheroo on number 7. You got to start with that switcheroo where you trade the x's and the y's. The x's and the y's flip-flop spots. Then you have to change it into the logarithmic form. This is a trick always. For any inverse function, this will come up later next week as well. So when you have something and you're like, trade it for the other form. So in this case, it's in exponential form. Put it in logarithmic form. So you have log base 7 of x equals 2y. And then you can go ahead and divide by 2. Y equals log base 7 of x divided by 2. Boom. Number 8. Number 8 may have been a little more straightforward, even though it's actually perhaps slightly harder. First of all, that ln business, it's great. It's log base e. So then when you do the switcheroo, x and y flip-flop. X equals log base e of y plus 6. Then trade it for exponential form. So this is actually the opposite of what's going on number 7. Trade it for exponential form. E to the x equals y plus 6. Then subtract 6, and you're done. That's all there is there. It's not simple, but that's what there is. Now, graphs. Like me some graphs. Okay. So, the graph of y equals log base b of x is shown below for b is greater than 1 and for b is between 0 and 1. That is true. In no way do they actually show you which one is which. It drives me crazy. Okay, so the one on the left is for b is greater than 1, and this is it. This is y equals log base b of x. They didn't show you which graph was which, and they didn't show you which graph on which graph grid was which. But the one on the left is when the base is more than 1, and on that grid it's only this bottom right chunk that is the actual graph. The other one is the exponential graph. I'll come back to that in a second. The right grid is for the b's that are positive, because simply logarithm doesn't make any sense if you have a negative base. But positive but below 1, and then in that case, this graph is a disaster. But it's this one, y equals log base b of x, and I can highlight it's that one. It still looks like a disaster, so let me kind of circle which one I'm talking about here. I realize that's a bit ugly. I apologize, but you are not certainly required to circle as badly as I do. Okay, so that's the log graph when the base is bigger than 0 but less than 1. Okay. Now, on to the second sentence in the paragraph above. Because y equals log base bx and y equals b to the x are inverse functions, the whole point of the logarithm is to do exponents backwards. The graph of y equals log base bx is the reflection of the graph y equals b to the x in the line y equals x. That's true. It's meant to explain to you why the graph shapes are what they are. At the end, you're probably better off just knowing what the graph what the graph shapes are, and then working with them correctly. Okay, now this is where things change. It's on the bottom. Note that the y-axis is a vertical asymptote. I'm going to underline that because that's backwards from before. On exponential graphs, the beginning half of the chapter, the stuff before spring break, it wasn't a vertical asymptote, it was a horizontal asymptote. So this is different. Of the graph y equals log base bx, the domain is, here we go, x is greater than 0, and the range is all real numbers. Okay, so remember when I was jumping up and down and screaming that the domain was always all real numbers for exponential graphs? It was true. It still is. Now, it's not the domain, it's the range, because it's the inverse function. The range used to be y is greater than 0 for exponential graphs, and now it's the domain for logarithm graphs. Inverse functions, so the domain and the range are switched. Always true there. Okay, thank you for watching.